All right, so we just finished talking about the motherboard, or MOBO for short, although nobody ever calls it MOBO. But now we're going to move on to the next component. And the next component is our central processing unit, or our CPU. And this is kind of what we call the brain of the computer. And what we mean by that is that it basically does the thinking involved in a computer. Now, we know that computers don't think. Well, yet. Artificial intelligence is on its way. But that being said, it doesn't truly think at this point. What it really does is it just performs two basic operations. Now over here, I'm just going to write real quick. Oops, got my eraser on. So an operation. What is an operation? In terms of a CPU, an operation is when it adds two numbers or compares two numbers. What I mean by that is something less than, is something greater than, is something equal to, etc. Right? That's all the CPU really does. Now, this is a very simplified lesson. It's meant for beginners. There's obviously much more going on, and I am oversimplifying things, but for all intents and purposes, this is all it really does. It's how an operation is just simply an addition or a comparison. Great. Okay. Let's move on. So, that's what its human body alias is the brain, because it does, quote unquote, the thinking. So how does it do that, or what does it do exactly? It controls the functionality and thinking of the rest of the computer, which is the thinking that we just mentioned. But how does it actually do that? Well, what it does is manipulates binary. Remember binary? We talked about this in the very first lesson with our introduction to programming. And binary is the machine code that the computer understands. Those ones and zeros. Remember this. 1, 0, 1, 1, 0, 0, 1, 0, and so on and so forth. And every single one of these numbers is part of the binary language. Binary is simply a collection or a sequence of ones and zeros. Each one of these numbers is called a bit. Right? So in this case, we have 1, 2, 3, 4, 5, 6, 7, 8. We have an 8-bit number here. That's an 8-bit number. Now, what is that in the number system that we know? Well, we'll come back to that later on. We're not quite there yet. So all a CPU does is basically it can take these binary numbers and it can add them together, or it can compare them, saying, is this one greater than this one? Is this one less than this one? Are they equal? Things like that. That's all it basically does. So where's the CPU located? Well, because the CPU is so important and the speed of the CPU is so important to our whole system because it does all the thinking, it needs to have as little gap between travel time of its data as possible. So with that in mind, it is actually located directly on the motherboard in this big square here. All right, now this is not, and not every motherboard looks like this, but they roughly have the same components involved. But so this big square here houses the CPU. That blue ring that you see there, it typically holds onto a fan, and that fan blows cool air directly onto the CPU. Why? Because the faster the CPU works, the more heat it generates, and it can actually overheat and sometimes even melt if your fan's faulty. I've had that happen to me myself. So that is where it's located. Now let's talk about a few extra details about a CPU, because there's a lot going on when we think of central processing units. First of all, well, when somebody says, hey, how fast is your computer, or what's the speed of your computer, what they're talking about is the term frequency. So what is frequency? Jumping over here again. Frequency, when we talk about a computer, is really how many operations, let's call it ops, can your computer do in a single second? And the unit we use is hertz. Okay? So how many operations per second? One operation per second would be 1 hertz. Great. So what does that actually mean? Well, let's jump over here for a second. This is a quick chart that shows you the different measurements of these hertz. So when we see a CPU runs at, say, a kilohertz, that means it can handle 1,000 operations per second, 1,000 additions and 1,000 comparisons per second. Megahertz is 1,000,000 operations per second, roughly. A gigahertz is a billion. A terahertz is a trillion. And there are more sizes. It grows and grows and grows and grows. Now, that being said, we don't typically use these bigger units or these smaller units when we're talking about our CPUs nowadays. When I was your age and I was in high school, we measured our CPUs in megahertz. My computer in high school ran at a whopping 33 megahertz. 33 megahertz. We had a special turbo button on it that would bump it up to 66. And you would be like, why don't you always have it at 66? That's ridiculous, Lane. Well, quite simply, it's like overclocking your computer nowadays. It just cranks up the speed, but when it does that, it generates more heat. When you generate more heat, you have to kick on the fan, things get loud, and it may not be what you want because you don't need it at that moment. Now, that being said, we always had that button on. So what does 33 megahertz actually mean? Well, if you look at this table, we know that 1 megahertz is the equivalent of 1,000,000 operations per second. So if we have 33 of those, that means that we have 33 times 1,000,000, which is 33 million ops per second. 33 million operations per second. You might be looking at that is a ton. That is a lot. The thing is that each one of those operations is only one tiny piece to a huge complex puzzle that your program is currently doing at that moment. So 33 million operations seems like a lot. But let's fast forward a little bit to modern times in terms of what you guys typically run. Now, your average computer right now will typically have a CPU in there, and the CPU might look something like this. And that CPU may rock a speed or a frequency of 3.2 gigahertz. That's fairly reasonable. So what does that mean? Gigahertz. Go over the table here. A giga is a billion. So that means that it's rocking 3.2. So 3.2 times a billion, or 3.2 billion ops per second. Now we're talking a big number. Things just got crazy. Look at the difference here. 33 million to 3.2 billion. That's a huge factor. If you think about this, that's a factor of 10. That's at least a factor of about 100. Right? It's about 100-ish. Well, what's the big deal? Well, CPUs aren't done yet. They're still growing. Your average CPU nowadays has multiple cores. What does that mean? It actually means that its CPU is actually broken down into a set of CPUs. So you might have 2 cores in your computer, which we'll call a dual core, dual meaning 2, or you might have 4 cores, which would be what we call a quad core, quad being 4. You can actually get CPUs with more cores, 8 cores, and so on and so forth. For example, like your modern gaming consoles usually have 7 or 8 CPUs on them. What does that actually mean? Well, what it means is that each one of these cores runs at 3.2 gigahertz in this case. So the actual frequency of your computer is different. The actual work it can do, the frequency stays the same, sorry, but the actual work it can do is quadrupled in this case. That means that what we're really looking at is, in this case, 3.2 billion operations times 4, which gives us, well, 4 times 3 is 12, 4 times 0.2 is going to be 0.8, so it's going to be 12.8 billion ops per second. Now we're talking. Things are getting big, really fast. And the more cores you have, the more operations per second you can do. Now, this is a paper number, which means we did the math on paper. In reality, when physics comes into play and things like that, that number would actually be a little bit less than that. We're going to lose certain things. We're going to lose some operations per second to various things. We can't really control that, but it's important to realize this. But look at this number now, 33 million to 12.8 billion. Now, looking at my PowerPoint, I've done the pre-calculation on this. What does that actually mean? That means that the computer that I had in 1997 runs at 1/390th of today's average computers that run a quad-core 3.2 gigahertz machine. Think about that, 1/390th. That means if you're waiting 1 second, I was waiting 390 seconds. That's crazy. That's absolutely crazy. It's like 6.5 minutes. That's nuts for your 1 second. But that is the nature of the beast. Technology has improved vastly over the years, so that's where we're at this point. I believe that's the end there. Yeah. Okay, so that's gonna be the end of this one. See you at the next one.